Hello everybody, and welcome to my small presentation for my final project in the class RBT 479 at the University of Advancing Technology. So for this presentation, what I had to do is I had to design a PCB board for something. And what I did is I designed a PCB board for a mini robot car that I'm going to use as part of my student innovation project. And what this is going to be is a small car that I can control with my smartwatch that is going to be able to do some pretty neat things. And so let's get started. So the design process came in three different phases. First I had come up with the idea, and then the design, and then the prototype. So the idea was to build a small robot car to be used with my student innovation project. And I found a free model on a site called Thingiverse that I'm modifying. I'm heavily modifying it. But here's a picture of what the robot looks like with the standard Arduino Uno on it. Pretty cool. The design, the first thing I did was I drew up a schematic. I had to find all the parts that I wanted on the internet and download them into OrCAD. And then I decided to actually, OrCAD worked pretty good, but I decided to use Fusion 360 and Eagle because I'm just more familiar with it. And to be honest with you, I really like the intuitiveness of it. Both programs are good, and I can do either or. Um, and I did have another, I do have a version on OrCAD, but I decided to use the Eagle one just because it just feels more comfortable for me. So here's the picture of the schematic. I have a standalone 18 mega 328p that's going to be integrated with it, and it has a pull-up resistor here for the reset. I do use a 16 megahertz crystal for it so it can run faster. And then I cycle it through these two capacitors. I also have a capacitor filter here for to filter out any noise that's going to be on the positive and negative. And I apologize, guys. My bird's sitting right next to me. He just woke up. I'll try to get through this as fast as possible. I have a H bridge right here that I use for two motors. The two motors are going to be right here and right here on each side. And I have a 9 volt barrel jack, so you can have an external power source that runs into a 5 volt um, 5 volt converter basically, so it won't go over 5 volts. And then I have an IR sensor over here that is going to sense IR addresses, so it'll make the robot, when you press buttons, it'll make the robot go forward, reverse, turn left, turn right. So the next thing was to build the 2D PCB board out of the schematic, and I did that, and it turned out really good. I designed it in OrCAD and Fusion 360 with Eagle. This is the Fusion 360 with Eagle version of it. I really like the way it came out. I use the top layer for the components and the bottom layer for routing, which is why the routing is in blue. If it was on the top, it would be red, but it's blue. And it turned out really good. It fits perfectly with the robot, and I'm really proud of it, actually. It's my first actual PCB, and I think it looks beautiful. So, but yeah, here's the 18 mega right here on the top, that long one right there. The bottom part right here is the H bridge. Off to your right, you will see the IR sensor, and one of the inputs for the motor. I actually put inputs there for the motor. On the left-hand side, you're going to see the crystal oscillator with the capacitors, a resistor, and an electrolytic capacitor just to filter out any kind of disturbance that could happen. Um, with any power source, I kind of recommend it. I do have it's a voltage converter, 5 volt voltage regulator. I'm sorry, 5 volt voltage regulator that's hooked up to a 9 volt barrel jack. Um, quite quite simple, but it works really good. Um, so here's the prototype after it was done. Like I said, it will fit perfect on the robot chassis. It does use an 18 mega 328p. I used 12 mils for the wiring just to be on the safe side. It started off with 6, but 12 is going to allow for a little bit more current if anything. And I figured a little bit would be, a little bit safer. Um, Probably not needed, but an ounce prevention is worth a pound of cure. So over here on the first picture, you're going to see the components on the actual PCB board. Um, the voltage regulator is a through hole design. If I were to just redesign it, I would use a surface mount design because it kind of sticks up a little bit. But it works. It's okay. It's not going to interfere with anything. And then on the bottom, you can see the routing um, that went through. I had a couple designs picked out. This is the one I like the most because it just looks kind of cool. So that's about it, guys. Thank you very much. My name is Jeffrey Koss. This is for a project, my final project in Robot 479. And here's my email address if anyone wants to contact me. Thank you, guys. Have a wonderful day.